Hi, today we're going to take a look at another manipulation technique using a geometric series. So let's imagine we have a geometric series and they tell me that the first term of that series is 2 and that the common ratio is 4, and we want to write a series for this. Well, it's pretty easy to do. So we're going to start off by writing out our first term. Now it's a series, so we're going to add the next term. Well, my R says to multiply this by 4 and I get 8. Multiply this by 4 again, I get 32, plus, and the next one, if I multiply this by 4, what do we get? 128, and so on and so forth. So it's a series, so remember we're going to put that plus dot to dot to dot. Now this is going to equal the actual series itself. Now we may recall from earlier, a geometric series is written from 0 to infinity. To get a geometric series, you can write whatever the first term is, 2 times that common ratio, 4, to the n. And just to verify that this works, if I let n be 0, I get 2. Let n be 2, we get, let n be 1, we get 8, so on and so forth. And we can do this for all sorts of geometric series. Like, let's say if I let the first term be, I don't know, 2, I'm boring, and let's say R is -3 this time. And I want to write the series again. Well, my first term is 2, multiply that by -3, I get -6. Multiply that by another -3, I get 18. And if you notice for this one, it's actually alternating for us. So we get -54, plus, and I write those first 4 terms, I go to dot, the dot, the dot. So in other words, this is going to become 2 minus 6, plus 18 minus 54 plus dot 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 equals, and now I write this as my series from 0 to infinity, and I just take my first term times it by my common ratio, -3 to the n. Now you notice this is alternating, so if I want to be fancy, I could just take out that -1 to the n, because I can distribute there, times 2 times 3 to the n. And there's our series right here. Now, another one we can take a look at. What happens if we have our common ratio, first term is 2 this time, but now our common ratio is, let's say it's x cubed. Writing it out again, it's going to become 2, put a splat there, plus this becomes 2x cubed plus 2x, multiply that, x to the 6, plus 2x to the 9th, plus so on and so forth. And if I write this as my general term, we're going to go from 0 to infinity of 2x cubed, be careful, to the n, or if you want to, 0 to infinity, 2x to the 3n. And there is our geometric series. Now, a lot of what we know about geometric series, we can use these to manipulate all sorts of problems. Now, let's take a look at review for a few minutes what a geometric series is. We just kind of discussed the first term is our a sub 1, and if I want to write a series, an nth term series, it's just going to be the first term times r to the n. So as a series, we go from 0 to infinity. It'd be our first term times r to the n. Now, what we're going to do today is we're going to write a series for this one, for the following. Let's write a series. Oh, hello. Focus, what happened there? There we go. We're going to write a series for the following. F of x equals 1 over 1 minus x. I want to write a series for this. Now, the traditional way is to just take the derivative, 4 or 5 derivatives, and use your Taylor polynomial. But we're going to use a geometric series, and we'll show you why this is considered a geometric series. It comes from the sum of a geometric series. And remember, for the sum, it's the first term divided by 1 minus that common ratio. So if I take a look here, they look almost the same. In other words, rational functions, which are not polynomial, can be gotten by our geometric series. In other words, what we're saying here is this 1 minus 1 over 1 minus x is the same as the first term over 1 minus the common ratio. And I just look at the parts. Well, my first term here is 1, matches with this, right? So I know my first term in my geometric series is going to be 1. My common ratio will look at the same parts. My common ratio is going to be x. So I could write my series 1 over 1 minus x as the following. My first term is 1. My second term is going to be multiplied by x squared, x cubed, so on and so forth. And that's going to equal our general term from 0 to infinity, and my first term times x to the n, right here. Now, the traditional way to do this, remember, if I wanted to do this traditionally without using the shortcut, we would have to take a few derivatives. And I'll show you that right here real quickly. The old way. Ready? The old way. Well, if I have f of x equals 1 over 1 minus x, my derivatives, this becomes, what's that, negative 1 over 1 minus x squared, but it becomes a positive because of chain rule. Okay. My next one, my second derivative, now gets a little bit trickier. This becomes 2 over 1 minus x cubed. My third derivative, 6 over 1 minus x to the fourth. Remember, they're alternating signs. They would only alternate signs, but you got that negative down below here when you chain rule. And my fourth derivative would be 24 over 1 minus x to the fifth. And this is a and the problem is this can take a little bit longer to do if you want to set this up. So you use your Taylor polynomial rule and set it up. So it takes a little bit longer to do it this way, or you can just know our little shortcut right here. Now, if you go to part 2, we're going to take a look at a bunch of other little problems just like these for geometric series. I'll see you there.